Researchers at Black Hat USA 2024 have uncovered vulnerabilities that could affect more than 30% of websites on the internet. Apache harbors critical vulnerabilities that could grant attackers root access, the holy grail of system compromise. And the most chilling part? These vulnerabilities have been hiding in plain sight, waiting for someone to exploit them. Today, we'll explore these critical Apache HTTP server vulnerabilities, showing you how they work and why they matter. Let's begin. The Apache HTTP server, often simply called Apache, has been the backbone of the internet for decades. It's the silent workhouse powering millions of websites worldwide. But recent research has exposed a troubling truth. This trusted guardian of our digital world isn't as secure as we thought. At Black Hat USA 2024, security researchers dropped a bombshell. They revealed architectural vulnerabilities within Apache that could potentially give attackers root access to servers across the globe. This isn't just a small bug or oversight, we're talking about fundamental flaws in the very design of Apache. The researchers identified 3 types of confusion attacks, discovered 9 new vulnerabilities, and revealed 20 different exploitation techniques, all backed by over 30 case studies. To grasp the magnitude of these findings, we need to take a step back and understand how Apache functions at its core. Apache operates on a modular design. Picture it like a massive Lego structure, with hundreds of small pieces working together to handle HTTP requests. These modules all rely on a shared structure called request_rec for synchronization, communication, and data exchange. As HTTP requests flow through the system, different modules modify this structure as needed. It's like a complex game of hot potato, with each module catching the request, doing its job, and passing it along. This design allows each module to focus on its specific task without worrying about the bigger picture. Sounds efficient, right? Well, here's where things get tricky. When you scale this up to hundreds of modules, the complexity skyrockets. The researchers found that many of these modules don't fully understand each other. There's a lack of deep comprehension about how their actions might affect other parts of the system. To make matters worse, there aren't stringent development guidelines in place to prevent inconsistencies. These gaps and inconsistencies create a perfect storm for potential exploitation. It's like having hundreds of security guards protecting a building, but they're all using slightly different rulebooks and don't communicate clearly with each other. At the Black Hat USA 2024, 9 vulnerabilities were uncovered, including CVE 2024-38472, which affects the Apache HTTP server on Windows, making it susceptible to server-side request forgery attacks using UNC paths. Next, there is CVE 2024-39573, a proxy encoding issue that could lead to dangerous security bypasses. CVE 2024-38477 introduces a crash that results in denial of service in mod_proxy through a malicious request, while CVE 2024-38476 shows how Apache HTTP server might exploit or use malicious backend application output to execute local handlers via internal redirects. Moving on, CVE 2024-38475 reveals a weakness in mod_rewrite, particularly when the first segment of substitution matches a file system path, and CVE 2024-38474 highlights a vulnerability related to encoded question marks in back references. CVE 2024-38473 brings to light another proxy encoding problem distinct from the one identified in CVE 2024-39573. CVE 2023-38709 exposes an HTTP response splitting vulnerability, which is particularly concerning. Lastly, there is a vulnerability, CVE 2024, that's yet to be fixed and publicly disclosed, adding to the list of potential threats that Apache HTTP server users need to be aware of. That's 9 vulnerabilities, each potentially compromising server security in different ways. But the researchers didn't stop there. They identified a new type of attack surface they called confusion attacks. Confusion attacks exploit the internal mechanisms and architectural design of Apache HTTP server. They occur when different modules within the server software fail to fully understand each other, leading to ambiguities in how they interpret the same fields. researchers have identified three primary forms of confusion attacks: file name confusion, document root confusion, and handler confusion. Let's break down each of these to understand their implications. File name confusion arises when certain modules treat the R file name field as a URL, while others interpret it as a file system path. This inconsistency leads to several security issues. For instance, path truncation can occur when modules like mod_rewrite truncate the path after a question mark, allowing attackers to bypass security checks and access restricted files. Next is document root confusion, which exploits the confusion between paths with and without the document root prefix. Apache HTTP server attempts to access both, often leading to unintended file access. This vulnerability can lead to source code disclosure, where attackers gain access to the source code of the server-side scripts like CGI or PHP files, especially when file paths are exposed outside the web root. Lastly, we encounter handler confusion, a vulnerability that stems from the interchangeable use of add_type and add_handler directives, which can lead to potential overrides or misuse of handlers. One such issue is the override of the handler, where a module accidentally overrides the content type, causing Apache to mishandle requests. This mishandling could expose PHP source code or trigger other unintended behaviors. Each of these confusion attacks demonstrates how subtle inconsistencies and legacy behaviors in Apache HTTP server can be exploited to compromise the security of web servers. They open up a wide range of potential attacks, from information disclosure to full system compromise. But why are these vulnerabilities so significant? Let's put this into perspective. Apache is used by approximately 31% of all websites worldwide. That's millions of servers potentially at risk. These aren't just small personal websites either. Many large corporations, government agencies, and critical infrastructure rely on Apache. The potential impact of these vulnerabilities is staggering. An attacker who successfully exploits these flaws can potentially gain unauthorized access to sensitive data, execute arbitrary code on the server, use the compromised server as a launching point for further attacks, or disrupt services through denial of service attacks. The researchers who discovered these vulnerabilities have demonstrated over 20 different exploitation techniques. They've also provided more than 30 case studies showing how these vulnerabilities could be exploited in real-world scenarios. One particularly alarming aspect of these vulnerabilities is their potential for chaining. An attacker could potentially combine multiple vulnerabilities to escalate their attack, moving from minor information disclosure to full remote code execution. For example, an attacker might start by using file name confusion to bypass access controls and read sensitive configuration files. They could then use the information gained to exploit document root confusion, accessing files outside the web root. Finally, they might leverage handler confusion to execute arbitrary code on the server. This chaining of vulnerabilities makes the overall attack surface much larger and more dangerous than any single vulnerability on its own. But it's not just about the technical aspect. These vulnerabilities also highlight a broader issue in software development and maintenance. Apache HTTP Server is an open-source project that has been around for decades. Over time, it has accumulated what developers call technical debt, outdated or suboptimal code that's difficult to change without breaking things. This technical debt, combined with the need to maintain backward compatibility, has created a perfect storm for security vulnerabilities. Features and behaviors that made sense years ago can become dangerous in today's more complex and hostile online environment. So, what can be done about these vulnerabilities? The Apache Software Foundation has already released patches for most of the disclosed vulnerabilities, and version 2.4.60 of the Apache HTTP server. However, the story doesn't end there. Patching these vulnerabilities is not a simple task. Many of the fixes are not backward compatible, meaning that updating to the latest version can potentially break existing configurations. This puts system administrators in a difficult position. They need to balance the need for security with the need to keep their systems running smoothly. Moreover, not all organizations can update their servers immediately. Some may be running on custom or legacy applications that aren't compatible with the latest version of Apache. Others may have complex infrastructures that require extensive testing before any updates can be rolled out. For the Apache HTTP server specifically, these vulnerabilities have sparked discussions about potential architectural changes. While backward compatibility is important, there may be a need for more fundamental changes to prevent these types of issues in the future. These changes won't happen overnight, requiring significant effort from the Apache development community, but they could go a long way towards preventing similar vulnerabilities in the future. As we conclude this in-depth investigation into Apache HTTP server vulnerabilities, it's worth reflecting on the broader implications. But they also demonstrate the power of security research. By identifying and responsibly disclosing these vulnerabilities, researchers have given the community a chance to address them before they could be widely exploited. This type of work is crucial for maintaining the security and integrity of the systems we all rely on. For system administrators and security professionals, the discovery of these vulnerabilities should serve as a call to action. It's crucial to stay informed about the latest security updates, to regularly assess and update your systems, and to always be prepared for the unexpected. For developers, these vulnerabilities provide valuable lessons about the importance of consistent design, clear documentation, and ongoing code maintenance. And for everyone who uses the internet, which is virtually all of us, these vulnerabilities are a reminder of the invisible work that goes into keeping our online world secure. As we move forward, it's clear that the security of the Apache HTTP server, and indeed all of our critical software infrastructure, will require ongoing attention, research, and collaboration. But with vigilance, dedication, and a commitment to learning from each new challenge, we can continue to build a safer, more secure digital world. What are your thoughts on these Apache vulnerabilities? Do you think open source projects face unique security challenges? Let us know in the comments below. And don't forget to subscribe to the channel.